Welcome to Skyscope, the podcast for amateur astronomers who want more than just the obvious. Every Monday, right here on this YouTube channel, we're bringing you observing tips.
That's the plan.
We're introducing objects that offer, well, a unique challenge for amateur or hobby astronomers.
Yeah, something to really sink your teeth into.
Exactly. So this week, for calendar week 27, we're taking a look at a true cosmic jewel. It definitely demands patience, but really rewards precision.
Oh, it certainly does.
It's the Cat's Eye Nebula, also famously known as NGC 6543.
This is Skyscope, challenging targets, real observing.
It's a truly extraordinary object. I mean, really one of the most complex and captivating planetary nebulae you can see in the northern sky.
And it's nestled right in Draco, right?
Perfectly nestled, yes, within that winding constellation. And what's absolutely fascinating and honestly often a bit confusing for people starting out is that despite its name, planetary nebula, it has absolutely nothing to do with planets. Zero.
Right, that name's a bit of a historical leftover, isn't it?
It really is. Its true nature is far more dramatic. It's essentially the beautiful dying breath of a star pretty similar to our own sun. It's elegantly casting off its outer layers as it, reaches the end of its life. And that process creates these incredible, intricate structures we get to observe.
That's such a crucial distinction to make. And the history behind it, the discovery and how we figured that out, it's quite a story itself.
Oh, yeah.
It was first spotted by William Herschel, wasn't it, back in 1786?
That's right, February 15th, 1786, legendary astronomer. But here's where its story gets really interesting for the history of astronomy itself.
Okay.
The Cat's Eye holds this really special place because it was the very first planetary nebula whose spectrum was ever investigated.
Wow, the first one. Who did that?
That groundbreaking work was done in 1864 by another pioneer, William Huggins.
Huggins, right. I've heard the name.
His detailed spectroscopic analysis, looking at the light broken down, delivered this, stunning revelation at the time. It definitively proved that these mysterious objects were actually gaseous. They weren't solid stars or clusters of stars.
Okay, bringing it back to observing today. From a practical perspective, how easy is it to actually see NGC 6543?
Well, from an observer standpoint, it's actually quite bright. It boasts a visual magnitude of about 8.1.
8.1, so that's well within reach for amateur scope.
Definitely, well within reach of even modest amateur telescopes.
Okay, so it's bright enough to spot, which is great news. But you also called it a challenge earlier. Can you walk us through what someone might first see, maybe with a smaller scope?
Yeah, you're right. The initial view is often just the beginning. The small, bright inner nebula itself is remarkably tiny in the sky, only about 20 arcseconds across.
20 arcseconds. Give us some scale on that.
Think about Jupiter when it looks biggest in the sky. This nebula's core is barely half that apparent size. It's a very compact core. However, and this is where it gets interesting, if you have the equipment for deep imaging, like astrophotography, those images reveal a much, much larger, fainter, extended halo surrounding it. That stretches out to about 300 arcseconds.
300, so that's, what, 5 arc minutes?
Exactly, a full 5 arc minutes across. And this faint halo, it's much older material, stuff that was ejected by the star much earlier in its life, probably during its red giant phase, way before the inner, brighter bit we see easily even started to form.
Okay, so for those of us eager to actually track it down, how do we pinpoint NGC 6543? Where should we be looking?
All right, first step, you need to locate the constellation Draco, the dragon.
Which is usually pretty easy. It winds between the dippers, right?
Exactly. It's quite distinctive, winding its way between the Big Dipper and the Little Dipper. So the Cat's Eye Nebula itself lies just west of the head of Draco.
West of the head, okay.
More specifically, it's positioned roughly 1/3 of the way along an imaginary line between the stars Delta Draconis and Zeta Draconis.
Now, you keep mentioning it's a challenge object, so maybe for listeners used to the immediate wow factor of something like Orion or Andromeda,
right?
What makes the Cat's Eye a step up in difficulty? And more importantly, what can we do to overcome those challenges and get the best possible view?
That's an excellent question.
Yeah.
Because, while it's bright enough to spot, truly resolving its intricate internal structure, that's where the real challenge lies.
Okay.
It demands a combination of factors. First, you absolutely need excellent seeing conditions.
Meaning stable air, not much twinkling.
Exactly. A stable atmosphere, minimal turbulence, so the starlight path is steady and sharp. Second, you'll need moderate to high magnification. You need to push the power a bit.
Any practical tips for getting those conditions?
Well, choosing a night when the air feels still is key. Often that's after midnight, when atmospheric currents tend to settle down a bit.
Let the scope cool down too.
Crucial. Allowing your telescope to thermally equalize, just letting it sit outside to cool down to the ambient temperature, is vital. And of course, making sure your telescope's optics are perfectly aligned or collimated.
So, assuming you've done all that, what does it look like initially in, say, a typical amateur scope?
In most amateur telescopes, it typically first appears as a simple, bright blue-green oval. Quite beautiful in its own right, actually. But those finer details, they remain elusive at first glance.
Okay, a blue-green oval. And then as you increase your aperture, maybe moving from a 4-inch to an 8-inch scope or even larger, what can someone expect then, pushing the limits?
Right, so in scopes maybe 8 inches and above, and this is important, under genuinely dark skies.
Away from city lights.
Way away from city lights where your eyes are fully dark adapted. Then observers might begin to detect its slightly elongated shape more clearly.
For objects like the Cat's Eye Nebula, a narrowband filter is highly recommended. Specifically, an O-triple-I filter.
The Cat's Eye Nebula responds exceptionally well to O-triple-I filters, especially in mid-sized telescopes. It really makes those subtle structures much easier to perceive.
What a cosmic puzzle box. Okay, so from its formation, its structure, maybe a binary.
Yeah.
Let's talk about its place in the cosmos. How far away is NGC 6543? And how old is this whole spectacle?
Right. Well, determining distances for planetary nebulae is actually quite challenging. You often see different estimates, which just highlights how tricky celestial map-making can be.
So there's some uncertainty.
There often is. But recent Hubble Space Telescope observations, which cleverly use the nebula's angular expansion rate, basically watching how fast it appears to grow over time, those suggest a distance of approximately 3,300 light-years.
Other methods sometimes place it a bit further out, maybe around 5,300 light-years, so there's still a bit of a range, but 3,300 is a good recent figure based on direct measurement of its expansion.
Its age is estimated to be about 1,000 years old.
Only 1,000 years? That seems really young, cosmically speaking.
It is. But remember, that's generally considered an upper limit. The ejected material inevitably slows down over time as it plows into stuff the star shed earlier, or just the general interstellar medium. So the true age might be slightly younger. Still, it's a relatively recent cosmic event.
1,000 years or so. Finally then, as we wrap up our look at the Cat's Eye, what is this astonishing thing actually made of? What elements are in there?
Well, like most things out there in the cosmos, it's primarily composed of the lightest elements. Hydrogen and helium.
The usual suspects.
The usual suspects, yeah. With only small quantities of heavier elements mixed in. Spectroscopic studies looking at the light signatures, they indicate a helium abundance of about 0.12 relative to hydrogen. But what's particularly interesting is the abundance of elements like carbon, nitrogen, and oxygen.
What about them?
Within the Cat's Eye Nebula, they are all notably higher than the amounts we find in our own sun.
Higher. Why is that?
It's not random. It's a direct result of nucleosynthesis, the process where stars fuse lighter elements into heavier ones in their cores.
That's incredible. So NGC 6543 is clearly way more than just another pretty target.
Oh, absolutely.
It's this vibrant, expanding window into how stars die, a cosmic puzzle with those amazing rings and hints of a hidden partner.
That sums it up perfectly. And while it might not, immediately dazzle you with the sheer size or brightness of some other nebulae,
right,
with careful observation, under those crucial dark skies, and using the proper magnification, maybe that O-triple-I filter, it absolutely becomes a true cosmic jewel. It really does seem to wink back at you like the watchful eye of some celestial cat, inviting you to look closer and deeper.
The Cat's Eye reminds us that even stellar death is incredibly dynamic and tells amazing stories, often with more twists than we expect.
Well said. Even dying stars keep things interesting.
So next time you're under dark skies, maybe give NGC 6543 a try, see if you can catch that beautiful Cat's Eye and ponder the forces that shaped it.
Definitely worth the effort.
This has been a fascinating look at the Cat's Eye Nebula. If you enjoyed this episode of Skyscope and you're hungry for more challenging, beautiful, and off-the-beaten-path objects in the night sky, make sure to subscribe to our channel.
Please do.
By subscribing, you won't miss a single target, tip, or opportunity to take your observing to the next level. Thanks for listening, and until next time, clear skies and steady seeing.
Clear skies.
Skyscope. Challenging targets, real observing.
Subscribe to our YouTube channel for weekly podcasts and more.